All right. Stoichiometry. What is this? My goodness. Stoichiometry sounds very complicated, but it's not. It's not complicated. Well, it could be complicated, but it's pretty easy once you see it, right? So we're going to talk about the part of stoichiometry is the mole ratio method, and it will be explained. So first of all, just what is it in simple terms? It is the amount of substances, chemicals, right, that are involved in reactions. So we're dealing with reactions. So when we have, and let's get our pen going here, we have remember, we're doing chemical reactions here. Reactants will yield products. And you know this. In case you're a little iffy on this part, you should go to my other videos that we talked about this. You should also know how to balance chemical equations, and we have videos on that also. So anyway, we know these chemical reactants will yield, that's the yield sign, products. And we want to know how much of this, how much of the reactants do we need? That's it. Do we need? How much do we need? Put a little question mark there. So how much of the reactants do we need? That is a basic definition of stoichiometry. I'll say it again, stoichiometry. Say that a couple times, you'll have it down. So let's do little examples here. We'll clarify it there. And by the way, we'll say the amount of substances. We're saying quantitatively, right, with numbers. All right, let's get a clear page. All right, so let me write it out for you. We'll use black. Why not? So stoichiometry. Right, when you heard it, you probably say, "What am I learning today?" The amounts of substances, chemicals, right, involved. And again, amounts, we're talking quantitatively. Get that in there. Quantitatively. The amounts of substances involved in reactions. In reactions. So in other words, using another color here, how much do we need? How much do we need? So we have to do math. Math's involved here. And we'll do it, and it'll be easy. You'll see. So for example, let's say we took H2O. We know H2O. We know it's water. We know it's dihydrogen monoxide. It's a chemical name for water. And it's interesting. It's an interesting compound. Remember, this is a compound because it's two or more different elements coming together. But hydrogen is very flammable. Hydrogen is flammable. And you may remember the Hindenburg in 1937 blew up in New Jersey, that German Zeppelin. I'll show you a picture of that. Let me just write this out first. So hydrogen is flammable, and oxygen feeds flames. This is not a mixture you want to mess with. So this is a dangerous combination, and it could be explosive. But guess what? It gives us water. It gives us water. But it's interesting how these two alone, if coming together, could be dangerous. In other words, breaking these bonds could be dangerous. And here's the Hindenburg, right? It blew up because it was this Zeppelin. This is a Zeppelin, not a blimp. Led Zeppelin, the band. Led Zeppelin, the band, formed in 1968. But this is a Zeppelin filled with hydrogen, blew up in New Jersey in 1937. 804 feet. In case you're wondering, right? So let's get back to that hydrogen and oxygen. So you just can't simply take hydrogen gas and add it to oxygen gas and you're going to get water. Well, first of all, there's the hydrogen, but the air we breathe is O2, first of all. We breathe in O2, we don't breathe in O1. Let's get a clear page here. So when we look at H2, and let's change to that color. So when we look at H2, there's bonds here. The bonds must be broken. Bonds must be broken. And to break them, we're going to use heat. Heat is involved. So heat is involved here. Heat will help break these bonds. And when you break the bonds, then you have, free hydrogen that can react with the O2. And the O2 bonds must be broken also. So what we get here in our formula is if we take 2H2 plus O2 and heat, we'll get what we want. We have our two water molecules. And you have to remember the term mole. Remember, we're talking about the mole ratios today. And we write mole as MOL. So mole is just telling you how much you have. So let's look at this. What do we have? We'll use green. So we have 2 mole hydrogen. And when we say 2 mole hydrogen, it means we have 2 hydrogen molecules. We have actually 4 hydrogen atoms, but we say we have 2 mole hydrogen, meaning the element, the molecule, and we have 1 mole oxygen. So that's what we have there. That's how we write what we have with mole. And it's going to yield 2 mole water, dihydrogen monoxide. And let's not forget that R. So we need to know how to write this, and we need to know that the formula is balanced. This is a balanced formula. So I'm going to write it over. Let's do it over. Make sure let's clear this out. Let's write this over again. And again, if you don't know how to balance equations, I have a video you can watch. I have the link below. And you can just look that up. It's not hard to balance equations. Just need practice. So let's see if this is balanced. Anyway, I'll show you very quickly. So over here we have actually 4 hydrogen atoms because we have 2 of these hydrogen molecules. Here's 1 hydrogen molecule, here's another, total of 4. And here we have 2 oxygen molecules. Well, we have 2 oxygen atoms, that is, because we have 1 oxygen molecule. And it's yielding. So now this is saying we have 2 water molecules. So we have 4 hydrogen because again, we have our water molecule, there's 1 of them, but we're saying we have 2 of them. So you can see we have the hydrogen is there, right? We'll just put a little dot for the hydrogen. And you know this. So we have 4 hydrogen and we have 2 oxygen. So this is balanced. That's the first thing when you're doing this. Make sure that it is balanced. The equations must be balanced. So to review so far in stoichiometry, make sure that you know how to balance the equations, make sure you know what moles are, and how to write those moles. All right. And the coefficients, remember the coefficients are the numbers next to the elements. They're going to tell us the ratios. And let's use blue. So right here here's a coefficient 2. You don't see a coefficient there, so it's 1, and there's a coefficient there. There's 2. So the ratio we have is 2, 1, 2. We're saying 2 hydrogen molecules, 1 oxygen molecule, and 2 water molecules. So that is the ratio. And then we can write these ratios. We can make 6 of them. So let's say, I can say 2 mole hydrogen over 1 mole oxygen. That's one ratio. I can also say, let's keep 2 mole hydrogen, and I can put it over 2 mole water. Just making ratios. Remember, part to part. Now all of a sudden we can make more. I can say 1 mole oxygen over 2 mole water. Now, can you make 3 more? See if you can make 3 more of these. I'll pause the tape. So what do you think, right? Let's clear it out. Let's make them again, because I ran out of room here. I'll make them again. Change the color. Let's just write the formula again. 2 H2 plus O2 will yield, remember these are the reactants, will yield to H2O. And remember, like I said, water takes heat. Heat must be that catalyst, that activation energy. You should be familiar with activation energy also. It's just a catalyst to jumpstart this whole thing. So we said that we had a ratio of 2, 1, 2. That's the ratio. Those are the ratio signs. So we said we made, and let's make them. We had 2 mole hydrogen over 1 mole oxygen. And if you just stick with hydrogen first, just get all the possibilities of hydrogen on top. Don't forget the mole. You have that. Now with hydrogen's on top, let's do oxygen on top. Now we have 1 mole oxygen over 2 mole H2O. We can do another one, 1 mole oxygen over 2 mole H2. And what other 2 did you find? Well, now let's do H2O on top. 2 H2O with 2 H2. And the last one will be 2 H2O with 1 O2. And of course, here we forgot to put mole. 2 mole. Always important. Make sure you put the mole in there. 2 mole. Don't get points taken off. 2 mole. Always double check your work. So remember, there is a difference in all these ratios. It's just like if you did, let's say, for example, in math, right? If we had 4 triangles and 2 squares. If I said, what's the ratio of squares to triangles? You have to put 2 to 4, which is 1/2, right? You can't put the triangle number first. So that's why it's important whatever is on top. So we have 6 ratios here. Very important. So now that we know these ratios and we use another color, blue, we have this ratio of 2, 1, 2. And I said, well, what if we wanted to have 8 mole of H2? If I wanted to have 8 mole of H2, what would be the O2? What do you think? What would be the O2 if we're using 8? Well, just look at it. To go from 2 to 8, we had to times by 4. So that was our magical number, 4. So if we had 2, 1, 2, and we want 8 mole hydrogen, then this will have to be 4 mole oxygen. And of course, it's the same number here. It would be 8. And what if we wanted 30? 30 mole hydrogen. What would the other 2 numbers be? Well, the last one will be 30 because it's the same number. But how many O2 would you have? 15, right? Because to go from 2 to 30, we need 15. 2 times 15 is 30, so 1 times 15 is 15. We'll have that. All right, let's use more examples. All right, here's a question. And I'm going to fill in the blanks here. Let's use red. So it says, what is the number of moles of H2O? So we'll say H2O that can be obtained from 4.0 moles of O2. And let's put our question mark there. So if we know the mole ratios, this can be solved easily. So remember, our equation was this, right? We knew we had this, just in case you forgot. And we yielded this. So we know our ratio of 2, 1, 2. So what is the number of moles of H2O, which is the product? Remember, this is the product that can be obtained from 4.0 moles of O2. So we want to have 4.0 moles of, we'll say 4.0 mole of O2, and we're going to times it by the mole ratio. And we want O2 on the bottom and H2O on top. So if you go back to the ratios, you'll be able to solve this. We'll have our equal sign. What do you think? Well, we know the ratios are here, 2, 1, 2. So we're going to have 2 mole H2O and 1 mole O2. And we put O2 on the bottom because we want to find H2O. And so we can easily get rid of the O2s. And it's just 1 here. So we don't have to worry about the 1. And we just times it. 4 times 2. And that'll give us 8.0 mole H2O. There's our answer. Very important in chemistry, though, is you try to get that, try to keep that as, instead of saying the ending result, make sure you put a 0 in your answer, even though you don't just say 8 mole H2O, it's 8.0. Chemistry teachers like that. So rewind the tape if you know that, if you don't know that, I mean, and let's do another example. All right, let's say we had, and why don't we switch to, well, switch to green. What if we had nitrogen gas, N2, right, plus H2, hydrogen gas? And that's going to yield, and again, these are our reactants, and it's going to yield the product of ammonia. It's going to yield ammonia, which is this. This is ammonia. All right, and so first thing, again, the first step you want to do is balance it. First step, step 1. Here's our steps, so making steps, right? Step 1, balance the equation. So over here we have 2, remember there's 2 nitrogen atoms. Here there's 2 nitrogen atoms. Here there's only 1, but here there's 3 hydrogen, so it's clearly unbalanced. This is unbalanced. So if I add a 3 here, a 3 here to the O2, let's see what happens. So let's balance the nitrogen first. Is the nitrogen balanced? It's balanced on this side, so we'll keep the nitrogen. That's balanced. The hydrogen is not balanced. We'll wait for the hydrogen to do one at a time. So if we put a 2 here with the N, now there's 2 nitrogen. But now the problem is we have 6 hydrogen because there's 2 of these 3 molecules, right? Here's 1 molecule hydrogen, 2 molecules, 3, which gives us, and we got 2 of those, 2 sets of those. That's why there's 6. So I need to get 6 over here. And over here we have 2 hydrogen molecules. So all I have to do is put a 3. And now it's balanced. See, it's balanced. Notice there's not a plus sign here. This is one compound together. These are separate. So now it's balanced. That was our first step. And again, if you need to learn how to balance equations, go to the other video link I have. So let's keep going. Let me clear it out, change the pen, put it back up here. So we have our balanced equation over here, yielding 2 compounds of ammonia. So what is our next step is to find out the coefficients. What is our ratio? What is the ratio we have? Well, we have 1, because there's only 1 here. If you don't see a coefficient, it's 1. Over here is 3. Over here is 2. So we know our ratio now. And if we have to write it, we'll say we have 1 mole nitrogen. And here we have 3 mole hydrogen. What do you think we have over here? We have 2 mole ammonia. 2 mole ammonia. So now we know our ratio. It's 1, 3, 2. So if I say, well, let's say we wanted to have 7 mole nitrogen, what would be, how would you fill these in? Well, just multiply it, right? To get to 7 with 1, we have to times it by 7. So we'll just, that's it. That'll be what we need. So in stoichiometry, it's telling you how much do we need of a substance, and this is what it's doing, using mole ratios. Now, what if we needed, let's say we needed 27. We had 27 mole hydrogen. What would these be? What would they be? Try that. And pause if you need to. Give you a couple of seconds. I'll switch to blue. So, look, we had 3, and then we ended up with 27. So what did we use? What number did we use? We used 9. 9 times 3 is 27. So 9 times 2 would be 18, and 9 times 1 is 9. That'll be our ratios. This is the substances we need. And from these 3, we can make 6 ratios. You can make your 6 ratios. So I'll give you a problem and see if you can figure this out. Let's say I said right here, we'll just make a little box here and say, How many moles? Sounds like some song, right? How many moles? Forgot that song. Remind me. How many moles of ammonia? Right? So we know that's ammonia, right? How many moles of ammonia can be obtained? The answer, my friend. That's it. Bob Dylan song. How many moles of ammonia can be obtained from 8 moles of nitrogen? Go back to the water one, what we did with the water. See if you can get this answer. I'll pause the tape. Pause the tape. You pause the tape. I'll give you a few seconds to pause it and see what you get up. See what you get. Think of the ratios now. And remember, the NH3, the ammonia, that's our product. All right. So if you pause the tape, if you didn't pause the tape, pause it now if you need to. So I'm going to say, we said from, right, from 8 moles of, we want 8 moles, 8 mole nitrogen. And we're going to times it. And if we're going to say 8 mole nitrogen, we need nitrogen on the bottom, and we need our product on top. Right? And so it says, and let's fix that line. So how many of this? So what ratio are we going to use? We want to use the ratio where we have ammonia on top and nitrogen on the bottom, and that would be 2 mole to 1 mole. We see the ratio 1 to 2, but we want ammonia, not pneumonia, on top, and that would be 2 to 1. So just cancel the N2s. We have a 1 on the bottom, so just multiply across, and your answer will be 16 mole ammonia. Excellent. So that is mole ratio method.